Hello guys, how are you today? So today I'm gonna be explaining the next 6 questions of the FRQ in the Level TN Term 1 final quiz, okay, for the AP Chemistry. So let's start with question number 7. A student has 100 milliliters of 0.400 molarity CuSO4 and is asked to take 100 milliliter of 0.15 molarity CuSO4 aqueous for a spectrophotometry experiment. The following laboratory equipment is available for preparing the solution: centigram balance, weighing paper, funnel, 10 milliliter beaker, 150 milliliter beaker, 50 milliliter graduated cylinder, 100 milliliter volumetric flask, 50 milliliter burette, and distilled water. Okay, so in part A, they said calculate the volume of 0.400 molarity CuSO4 required for the preparation. They want us to make, or they want the student to make 10 milliliter of 0.150 molarity from the 0.400 molarity. So what can we use here? We can use C1V1 is equal to C2V2, right? So I have concentration 1, which is 0.400 times V1 is equal to C2, which is 0.150 times V2, which is 100. So V1 is equal to 0.150 times 100 over 0.400. So that will give me my answer to be 37.5 milliliters, to the correct number of significant figures. Okay, that is perfect. Let's check in part A what's the answer. In part A, they said that we earn 1 point, which is the maximum if we write C1V1 equals C2V2 or M1V1 equal M2V2. And we need to solve, and we'll get our answer to be 37.5 milliliters. Now, if we move on to part B, what do they ask? They said in part B, briefly describe the essential steps to most accurately prepare the 0.150 molarity CuSO4 aqueous from the 0.400 molarity CuSO4 aqueous. Okay, so how should we prepare it now? Okay, so very simply, if you look at the answer key, what does it say? It says we have 2 maximum points, and what are these 2 maximum points for? First point is earned for using the burette to measure 37.5 milliliter of 0.400 molarity solution. Molarity, this is very important. Then after, what did they do? They said you will open the burette and you will release the CuSO4 solution into the volumetric flask, and then pay attention, you need the 100 milliliter volumetric flask and here the 50 milliliter burette, okay? And then you'll use the 100 milliliter volumetric flask and you will fill it to the top in order to get what? In order to get the final answer, or like the final solution, okay? So you just fill it to the top of the 100 milliliter volumetric flask, okay? Now in part C, what are they saying? They are saying the student plans to conduct a spectrophotometric analysis to determine the concentration of CO2 plus in a solution. The solution has a small amount of CONO3 aqueous present as a contaminant. Okay, so what does this mean? It means this is unnecessary. We need to get rid of it somehow. The student is given the diagram below, which shows the absorbance curves for aqueous solutions of CO2 plus aqueous and Cu2 plus aqueous. They said the spectrophotometer available to the student, okay, the spectrophotometer available to the student has a wavelength that ranges from 400 nanometers to 700 nanometers. This is very, very, very important. What wavelength should the student use to minimize the interference from the presence of CO2 plus aqueous ions? Now, logically speaking, you will go to the graph. You see, okay, my CO2 plus maximum is here, and where's my minimum value? It is over here. So it's in the range of 650 almost. I'm gonna say 660 to 700 nanometers. So any value you put from here is supposed to be considered correct, okay? Now, what did they say in the answer key? They said part C, you get any wavelength that ranges from 650 to 700, and you'll get what? You will get the maximum point, which is what? Which is 1 point. So we'll move on to question number 8. What does it say in question number 8? So they said propanoic acid C2H5COOH is an organic acid that is a liquid at room temperature. An incomplete Lewis diagram for the propanoic acid molecule is provided in the box below. Complete the diagram showing how the remaining atoms in the molecule are arranged around the carbon atom with an asterisk. You should minimize formal charges and include any lone pairs of electrons. So here they're telling us that this is C2H5COOH. Right? So they already drew for us C2H5. This is C2H5. Now what's left for us is COOH. Now COOH, it's COO and then H. The O and H are bonded together, not the H is bonded with the carbon. No, it is the hydrogen that's bonded to the oxygen and not to the carbon. Now this leaves us with what? If we draw it here, right? Because we have an oxygen, another oxygen, and then a hydrogen bonded to the oxygen, because look here, it's OH, oxygen, and then hydrogen bonded to the oxygen. And then what do we have left? Now this is very important to know. We should know that always carbon makes 4 bonds, right? And oxygen makes 2 bonds. This is very important to know. So because carbon makes 4 bonds, and I look at what I have 1 bond here, 1 bond here, 1 bond here. I have 3 bonds. I need 1 more bond. But I also know that oxygen makes 2 bonds, and this oxygen has 2 bonds, so I cannot put the double bond here. Instead, this oxygen has only 1 bond, so I can put my double bond over here. So this is what my structure looks like. Don't forget to add the the lone pairs. So here we have lone pair like this, and here we have a lone pair like this. So this is what the final answer is supposed to look like. Now we'll go double check here. As you can see, this is what the final answer looks like, and you will get 1 mark if you draw it like this. We'll move on to part B. They said identify the hybridization of the carbon atom marked with the asterisk. So if we come here, like this is what we drew, right? Our carbon atom is it's gonna be our central atom A. And then surrounding we have an X, and then X, and there's no lone pair. So the shape of this is what is AX3. Now, you don't take into consideration A, you take into consideration the electron domains. So I have only 3 bonded electron domains, right? So what does this mean? This means I should have 3 electron domains. So it's gonna be what? It's gonna be sp2. Why? Because I have 1 plus 2, so that will make for me what? That will make for me 3 domains. Okay, so that is it for part B. We'll move on to part C. Propanoic acid has a lower boiling point than butanoic acid. Okay? First of all, propanoic acid is whatever we had above. Butanoic acid is whatever we have here. They're saying it has a lower boiling point than butanoic acid. Now, propanoic acid is C2H5COOH. First of all, identify all the types of intermolecular forces present. For sure, we have a hydrogen bond, because we have oxygen bonded to a hydrogen. This is a hydrogen bond. And then, I believe they're both polar. If I'm mistaken, we can check in the answer key and we can correct ourselves, okay? So I believe they're also both polar, and they have LDF forces. Okay, so if I go to the answer key, it's part C. Okay, so I have London dispersion forces, dipole forces, and hydrogen bonding. Now, dipole forces is correct, that is true. However, they said you don't need to write it. If you write it, you're not gonna earn the point. What's important to write is the hydrogen bonding and the London dispersion forces, and don't forget as well to include the dipole in all scenarios, okay? Now, which of the following types of intermolecular forces that you identified in part CI is most responsible for the difference in boiling points for the 2 acids? Whenever they say difference in boiling points, directly you think of the London dispersion forces. These control everything when we're talking about boiling points and melting points. Now, that is for part I. And for part II, what do you get? Your answer should be what? It should be the London dispersion forces, okay? That's it for question number 8. We'll now move on to question number 9. What does it say in question number 9? The complete photoelectron spectrum of elemental phosphorus is shown below. On the graph, circle the peaks that corresponds to the valence electron of phosphorus atom. This is very easy. The last close together peaks are usually what are usually the valence electrons. So if you come to the answer, you will see, yes, this is my answer. In the spectrum, the peak labeled X correspond to electrons with a binding energy of about 13,500 kilojoules per mole. Okay, X is there. Identify the subshell that the electrons occupy in the phosphorus atom. Okay, so we need to find the subshell. We start by naming them all. This is gonna be 1s2, 2s2, 2p6, 3s2, and 3p3. Now, I look at my whatever I wrote and I see that the peak with X is what is 2p6. That means the subshell is supposed to be the 2p subshell, not 2p6 subshell. It's the 2p subshell. You only write 2p and not 2p6. Okay, it's the 2p subshell. Now in part C, what are they saying? Calculate the minimum frequency of electromagnetic radiation that would be needed to eject an electron from the subshell that you identified in part B. Now, they told us already they have the energy E. We should have Planck's constant memorized. What's Planck's constant? It's 6.62, but they used it as 6.63 times 10 to the power of minus 34. Oh, actually, I missed something very important. This is the energy per mole. They want the energy to eject a singular electron. We know that in 1 mole, according to Avogadro, there should be 6.02 times 10 to the power of 23 electrons, or like protons, you know, or particles, okay? So we need to use Avogadro's number. Basically, what they're telling us is this is the energy per mole. We need to change it to energy per electron because we need to eject a singular electron, okay? So now Planck's constant, 6.63 times 10 to the power of minus 34, right? So now what do? I take 13,500. Okay, so 13,500 kilojoule. We need to change it into joules, so we'll multiply by 1,000. Divided by what? Divided by Avogadro's number, 6.02 times 10 to the power of 23, right? What will I get? I'll get as my answer 2.24 times 10 to the power of minus 17 joules per electron. So this is now what? This is now my E per electron, okay? Now I can find the frequency, because frequency is equal to the energy divided by Planck's constant. So it's 2.24 times 10 to the power of minus 17 over 6.63 times 10 to the power of minus 34, and this should give me an answer of 3.38 times 10 to the power of minus 16. And, sorry, not minus 16, 3.38 times 10 to the power of 16. And what is the unit? The unit is hertz, or per second squared. That's question number 9 done. We'll move on to question number 10. What does it say? It says, some binary compounds that form between fluorine and various nonmetals are listed in the table above. A student examines the data in the table and poses the following hypothesis. The number of F atoms that will bond to a nonmetal is always equal to 8 minus the number of valence electrons in the nonmetal atom. Based on the student's hypothesis, what would be the formula for the compound that happens between chlorine and fluorine? So he said, whatever compound you have, you will take the group, right? Okay, the valence electrons or the group number, and then you will do 8 minus the valence electrons, and you will get what? You will get how much of this atom you have, right? So for example, chlorine and fluorine. Fluorine will be F. Chlorine is group 7, so 8 minus 7, this will be 1. That means I should have 1 chlorine. So based on his hypothesis, we should get ClF. Now, in an attempt to verify the hypothesis, the student researches the fluoride compounds of the other halogens and finds the formula ClF3. In the box below, draw a complete Lewis electron dot diagram of ClF3. So we have Cl over here, and then F, F, and F, right? Now, Cl is which group? It's group 7 plus 7 times 3. How much is that gonna be? That's gonna be 28. Now we subtract from it what? We subtract from it 6 electrons because we used 3 pairs. So minus 6, this will give us an answer of 22. Now 22 divided by 2, this should give me 11 electron pairs. So I should have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, and 11. So this is what my structure looks like. So yeah, this is what my structure is supposed to look like. We get 1 point for writing it, for drawing it correctly. Part C. Two possible geometric shapes for the ClF3 molecule are trigonal, planar, and T-shaped. The student does some research and learns that the molecule has a dipole moment. Which of the two shapes is consistent with the fact that the ClF3 molecule has a dipole moment? Justify your term, or justify your answer in terms of bond polarity and molecular structure. So basically they told us he ended up identifying two shapes, which is either trigonal, planar, or T-shaped. How do I know which shape it is? Very simply, they told me that it has a dipole moment, meaning that the net dipole is not equal to 0. That means it's what? It's a polar molecule. It's a polar molecule, first of all, and we know its shape, which is what? Which is ClF3, right? So it would be AX3E2. AX3E2, already we should know that it's what? It's a T shape. Now, since it is a T shape, right? That means it's what? That means it's asymmetrical. Because it's asymmetrical, that means directly it's what? It's gonna form a polar molecules because the dipoles don't cancel. Now, this is how we would go usually. Instead, we need to go backwards. Okay? Instead, we need to use all of this information to explain why it is a T-shape. First of all, my dipoles don't cancel. If my dipoles don't cancel, that means it's a polar molecule. Trigonal, planar, okay, is asymmetrical molecule. T-shaped is an asymmetrical molecule, right? ClF3 has similar surrounding elements. So this is not gonna determine whether it's gonna be polar or non-polar. Instead, the shape is gonna determine. Now, if it's a non-polar shape, that means it should be a symmetrical shape. So trigonal, planar is a symmetrical shape. That's why it will result in a non-polar molecule, whereas T-shaped is a non-symmetrical or asymmetrical molecule, so it will result in a what? In a polar molecule. Okay, so how did they explain it in part C? They said the molecule is T-shaped because T-shaped structure is asymmetric with dipoles that do not cancel out but produce a net dipole. Okay, so basically something like this. Now what does he say in... Okay. Now we continue reading. In an attempt to resolve the existence of the ClF3 molecule with the hypothesis stated above, the student researches the compounds that form between halogens and fluorine and assembles the following list. In this list, the halogen F would give me F2. Cl, what did we say it gives me? It gives me Cl and not Cl. It gives me ClF and it gives me ClF3 only. Then Br gives me BrF, BrF3, and BrF5. And then I gives me IF, IF3, IF5, and IF7. So what can I deduce from this? From this, I can understand that this has, like fluorine, bonds with one fluorine. Here, it bonds with either 1 or 3. Here, it's either 1 or 3 or 5. Here, it's either 1 or 3 or 5 or 7. So what are these? These are odd numbers. So there's an odd arrangement of fluorine. Okay? And it increases by 1. It increases by 1 extra compound as we go down the group. As we go down the group. Okay, so I don't know if I worded it correctly, but we're talking about which part? Oh, part D, based on concepts of atomic structure and periodicity, propose a modification. Okay, so I just stated the modification. Now, in part D, so how do they want us to read it? First of all, regarding the atomic structure, we have an odd number of F atoms because I said 1 or 1 and 3, 1, 3, 5, 1, 3, 5, 7, right? And then regarding periodicity, as the atomic number of central halogens increases, then the number of F atoms increases. That's true. Okay, that's it for question number 10. We'll move on to question number 11. For parts of the free response, blah, 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 okay, answer the following question about solutions of NaCl and CaCl2. Ions in a certain volume of 0.20 molarity NaCl are represented in the box above on the left. In the box above on the right, draw a particulate diagram that represents the ions in the same volume of 0.10 molarity CaCl2 aqueous. Okay, now all of this resorts to what? Resorts to the number of moles. First of all, CaCl2. I can find the mole ratio. It's Ca2 plus and then Cl minus, but it's not balanced out, so I need to put a 2 over here. So now it becomes what? It becomes 1 Ca2 plus to 2 Cl minus. So the ratio of moles is 1 to 2. Now, after finding this very important information, we should find the number of moles of CaCl2. First of all, we know that the number of moles of NaCl is basically how many particles do I have in the box, okay? Now, they told us that the concentration of NaCl was 0.20 and the volume, we're going to call it X. For us, now the CaCl2, what we're going to draw, the concentration is 0.10. However, it's the same exact volume, which is X. Now, what's the ratio of NaCl volume to the CaCl2 volume? This is 0.20x to 0.10x, so it's going to be what? It's going to be 2 to 1. So what does this mean? This means the number of moles I have for NaCl, I'm going to have half of it for CaCl2, right? So, first of all, I count how many moles do I have of Cl minus? I have 1, 2, 3, 4, 5, 6, and 7. How many moles do I have of Na plus? I have 1, 2, 3, 4, 5, 6, 7, and 8. Oh, I forgot to count one more Cl minus. So I have 8 moles of Na, 8 moles of Cl, right? So 8 moles of Na plus, 8 moles of Cl minus. So that means in total I have 8 moles of NaCl. What does this mean? This means I'm going to divide it by 2 to get 4 moles. And this 4 moles is for what? This 4 moles is for CaCl2. But I don't forget my ratio. My ratio is 1 to 2. So Ca2 plus and Cl minus, it's a ratio of 1 to 2. So what does this mean? This means my Ca2 plus, which is the small circle that's open, and then my Cl minus, which is the big circle that's filled in, right? I'm going to have 4 moles of Ca2 plus. So 1, 2, 3, 4. And then I'm going to have 4 times 2 moles, which is how much? Which is 8 moles of Cl minus. So 1. I don't think I can copy, so I'm going to do it fast. 2, 3, 4, 5, 6, and 7. And one more, which will give me what? Which will give me 8. So this is what it's supposed to look like. If we go back to the answer key, we should have 4 unshaded circles that represent Ca2 plus ions. We have that. And 8 shaded circles that represent Cl minus ions. We have that as well. We'll move on to part B. What does it say? It has briefly explained how the presence of charged ions in ionic solids such as NaCl help to explain why NaCl is soluble in water. Now let me check the marking scheme to see how exactly they would want us to explain this. The response indicates that the charged ions are attracted to polar water molecules, or that the positive and negative ions are attracted to the water molecules which have positive and negative ends. So this is all based on the polarity of these ions and the polarity of water. So you can say that charged ions, okay, are attracted to polar water molecules. What does this mean? This means I have my Na plus and I have my Cl minus. It's soluble in water because my water molecule, which is O, which has a partial negative, right? It will attract to my Na plus. And then what do I have left? I have my H plus and my H plus. Okay? Whereas for my Cl, my H partial plus are gonna attract to it, right? One H partial plus is gonna attract to it, and then I will have my oxygen partial negative, and then I will have my other H partial plus. So this is why what? This is why charged ions are attracted to polar water molecules. We'll move on to part C. What volume of 0.20 molarity NaCl contains 10 grams of NaCl? Okay, this is all about equation. What do we know? We know that the number of moles is equal to concentration times volume, which is also equal to the mass over the molar mass. Number of moles equal, or let me just say concentration times volume. They want to find what? They want to find volume. So volume is equal to the mass over molar mass times what? Times concentration. So it's gonna be 10 over 58 times 0.20. I will get my volume to the correct number of significant figures. I believe it's gonna be 0.86 liters, if I am not mistaken. Okay, so 860 what? Milliliters. They put it in milliliters, but of course you can put it as 86 liters. I'm not sure if it's also correct, but I think they're moving more towards milliliters. What did they ask us? They didn't tell us the unit, but in all scenarios, keep it in milliliters. So we just learned that if I get my answer in liters, I will change it directly to what? I will change it directly to milliliters. That's it for question number 11. I'll move on to question number 12. What does it say? It says, a student is given a sample of CuSO4 solid that contains a solid impurity that's soluble and colorless. The student wants to determine the amount of CuSO4 in the sample and decides to use a spectrophotometer. First, the student prepares a calibration graph by measuring the absorbance of CuSO4 solutions of known concentration. The graph is shown below. The student dissolves the entire impure sample of CuSO4 in enough distilled water to make 100 milliliters of solution. Then the student measures the absorbance of the solution and observes that it is 0.30 absorbance. They want us to determine the concentration. So you just look at the graph, you see 0.30 here. I will come. It's almost what? It's almost 0.15, halfway. 0.15 molarity. This is my concentration. Okay, we move on to part B. Calculate the number of moles of CuSO4 that were in the impure sample of CuSO4 solid. How do I find the number of moles? Number of moles is equal to concentration times volume. So 0.15 times my volume, which is 100 milliliters over 1000 to get my answer in liters. So 0.15 times 100 over 1000. I will get my answer to be 0.015 moles. Right, so what did they say in part B? They did the same exact thing. They changed it from milliliter into liter, and then they got it to be 0.015 moles. What did they say in part C? In part C, they said, in addition to the number of moles of CuSO4 calculated in part B, what other quantity must be measured in order to calculate the mass percentage of CuSO4 in the impure sample of CuSO4? They want to find what? They want to find the mass percentage of CuSO4 in the impure sample of CuSO4. How do we find that? In order to find that, we would need to measure what? We would need to measure the mass of the impure sample. Why? Because I already have the number of moles of CuSO4, which is 0.015, right? 0.015 mole. And then I can find the molar mass, and I will multiply it by the molar mass, and I will get what? I would get my answer, which is the mass of CuSO4, the pure CuSO4. Now, how do I find the mass percentage? It's going to be this mass of CuSO4 over the impure mass times 100. So the only thing left for us to find is what is the impure mass. So what should we do in this scenario? We should say that the response indicates blah, blah, blah. Okay, so basically, we should say that the mass of the sample, which is the impure sample, must be measured. Now, part D, what does it say? A particulate drawing of a single Cu2 plus ion is shown in the following box. Draw two H2O molecules in the box to show the most likely orientation of the H2O liquid molecules around the Cu2 plus. Okay, so Cu2 plus is positive. That means my water molecule, my two water molecules, okay, are gonna be represented like this. Why? Because here is my partial negative oxygen and my partial negative oxygen. They're gonna be attracted to what? To the positive. And what's remaining is my partial positive hydrogens. They're gonna be facing the other way. So this is how it's supposed to look like. Let us see. It said the drawing should show two molecules of water oriented so that the large circle, which is oxygen, is closer to the Cu2 plus than the two small circles. So that's it for this video. Thank you guys for watching. I hope you enjoyed and have a wonderful day.